Okay. Good morning, everyone. Okay, so we're here once again, and let's recap on our previous class, which we treated some year 6 concepts like the knowledge collecting operator, the optional chaining operator, and other year 6 features. So today will be more of talking and less of typing. We'll talk more and type less. So I guess we should all pay attention because the information will be a kind of vital. So let's just pay attention. Now today class, we will be jumping to core NodeJs. So we'll try to understand the NodeJs philosophy and design fundamentals. What makes NodeJs so awesome and beautiful? So under the philosophy and design fundamentals of NodeJs, we have asynchronous non-blocking I/O, single-threaded event loop, the common JS modules, the callback pattern, error-first callbacks, design patterns, middleware pattern, and last but not the least, dependency injection. So we'll try to explore these concepts and try to understand how NodeJS is built and how it handles a synchronous non-blocking I/O. So first of all, let's begin with synchronous non-blocking I/O. So what is asynchronous non-blocking I/O and why is it important in NodeJS? So in traditional web servers, what happens is they rely on synchronous input slash output. That is I/O means input slash output. That is input output. So the traditional web servers rely on synchronous I/O, meaning the server waits for an I/O operation, like reading a file or making a network request to complete before processing the next request. So it can lead to a kind of poor performance, especially when you're dealing with concurrent requests. So what NodeJS does, it takes a different approach by using asynchronous non-blocking I/O. So what this means is, first, the asynchronous, the operation don't block the main thread of execution. So the server can initiate an I/O operation and continue processing other requests while the I/O operation is happening in the background. The non-blocking, so the server doesn't wait for the I/O operation to finish before moving on. It can handle other requests efficiently. So we have two things here. We have asynchronous and we have non-blocking. Asynchronous here simply means operations not having to block the main thread execution. That is the server initiating an I/O operation and continue processing other requests while the I/O operation is happening in the background. Now, the non-blocking here simply means the server doesn't wait for the I/O operation to finish before moving on. That is, it can handle other requests. Let's say it has an I/O operation going on that is being handled, and another comes in, it will still handle that concurrently without having to wait for the previous one to finish. So that is just the asynchronous and non-blocking I/O of NodeJS, and that's what makes it awesome. So what are the benefits of asynchronous and non-blocking I/O? Okay, The benefits of asynchronous and non-blocking we have a few, and I will just mention a few out of many. And first is scalability. NodeJs can handle a large number of concurrent requests without having to sacrifice performance. So it makes it ideal for real-time applications and APIs. Number one, scalability, and the second one is responsiveness. So users don't experience delays while the server waits for I/O operations. The server remains responsive to new requests. Even though the server is handling other I/O operations in the background, it's open to incoming requests. So you can still send another request and the server will handle it successfully. So that makes it asynchronous and non-blocking. Efficient, the number third one is efficient resource utilization. Since the main thread isn't blocked waiting for I/O, NodeJs can make better use of system resources. Okay, under the asynchronous and non-blocking I/O, we have the event loop and callbacks that makes this possible. So to achieve asynchronous behavior, NodeJs relies on an event loop and callbacks. Now, what is an event loop? So an event loop is just a core component that continuously monitors for events like I/O operations completions. So when an event occurs, the event loop places a callback function associated with that event in a queue for execution. What are callbacks and what function do they perform in I/O operations in event loops? So these are functions. The callbacks are functions that are passed to I/O operations. So when the operation completes, the corresponding callback is added to the event loop queue for execution at the next opportunity. So when an event occurs, the event loop places a callback function associated with that event in a queue. So this callback function are passed to I/O operations. When the operation completes, the corresponding callback is added to the event loop queue for execution at the next opportunity. This simply means when it gets to the turn of that event, the callback function will be executed. The callback function associated to that event will be executed in that queue as follows. So the design patterns for asynchronous programming, we have callbacks, promises, async, await, and I think these three are the most important: callbacks, async, await, and promises. So the traditional way of handling asynchronous operations in Node.js can lead to nested callbacks, which is also known as callback hell for complex logic. Now, promises are used to solve this problem. A more structured approach for handling asynchronous operations are promises. Promises represent the eventual result of an operation, like either it's successful or it has failed. It represents either success or failure. Then comes in async await. So async await, this is just a syntactic sugar built on top of promises. It only makes asynchronous code look more synchronous and easier to read. So that's basically how the asynchronous non-blocking I/O is. That's how it works under the hood, making use of event loops, callbacks, event loops and callbacks to handle operations successfully without blocking the I/O. So moving on, we have single-threaded event loop. I had no time to prepare notes for this, but maybe after this class, if I have time, I will prepare some notes for you so you can go try and get to understand everything in depth. Or you just have to pay attention for now. So, yeah, and if you have any questions, you are free to raise your hand so I can quickly answer you, then we'll proceed. Next on the list is single-threaded event loop. The question here is, if JavaScript is single-threaded, then why is the IO non-blocking? So here comes our answer. At the heart of NodeJs, it has a single thread that executes JavaScript code. So this thread is responsible for handling all requests, that's passing income data and generating responses. So what makes possible the asynchronous non-blocking IO? So the key to NodeJS concurrency lies in the use of asynchronous non-blocking IO operations. So this means that when a request comes in and requires an IO operation, like reading a file or making requests or other things, NodeJS doesn't wait for the operation to finish before moving on. Instead, it initiates IO operation and then continues processing other requests, which uses event loops and callbacks. So this is how it works in practice. So when a request arrives at the NodeJS server, the main thread starts processing the request. If the request requires an IO operation, the operation is initiated and a callback function is registered with the event loop. So the main thread continues processing other requests or goes idle if there are no other requests waiting. Now, when the IO operation completes, the event loop triggers the corresponding callback function from the queue. When the IO operation completes, the event loop will trigger a corresponding callback function from the queue. That is, that callback function that is associated with that very event, that event that occurred, the callback function will be triggered from the queue. So the callback function handles the result of the IO operation and completes the original request. Let's assume you have an IO operation that is to read a file. Then there's a callback associated with it. After reading that file, it will pass the result to the callback function. Then the callback function will complete what you are to do with that result next. So that is where the callback function handles the result of the IO operation and then completes the original request. So the response is then sent back to the client. When a request arrives, let's go over it once more. Let me see if I can actually follow step by step as I did. A request arrives at the NodeJS server. The main thread starts processing the request. Now, if the request is an IO operation, the operation is initiated and a callback function is registered with the event loop. Now, the main thread continues processing other requests or goes idle if there are no other requests waiting. Now, when the IO operation completes, the event loop will trigger the callback function associated with it. Then the callback function will handle the result of the IO operation and then completes the original request. After the original request is being completed, the response is then sent back to the client. That is how NodeJS handles asynchronous operations using just a single thread. So benefit of the single-threaded event loop. And the most three important benefits of the single-threaded event loop are scalability and simplicity. So in scalability, it is scalable by not blocking the main thread on IO operations. So NodeJS can handle a large number of concurrent requests efficiently. In simplicity, the single-threaded nature can make NodeJS easier to learn and reason about compared to multi-threaded environments. So there are also some drawbacks of the single-threaded event loop, like the CPU-bound tasks and the callback hell, as I earlier said. When dealing with many nested asynchronous operations, callback-based code can become difficult to read and maintain, which is known as the callback hell. And under the CPU bound tags, NodeJs is not ideal for CPU bound tasks, like tasks that are bound to the CPU. Like tasks that require a lot of processing power. Since there's only one thread, extensive computations can block the event loop and then prevent the server from handling other requests. Let's assume you have a task that requires a whole lot of processing power and need like 5 minutes. So it's just a single thread, and the computation will block the event loop and then prevent the server from handling other requests, because it's not actually an IO operation. It's an expensive operation that needs CPU power. So these drawbacks are also addressed. They are addressed. So the non-blocking operations, which focus on non-blocking blocking operations whenever possible to avoid blocking the event loop. And then the promises and the async await, which uses promises or async await for more structured and readable way to handle asynchronous operations, especially for when the logic is complex. And then Node.js also has it has worker thread. For CPU bound stacks, Node.js now it has worker threads, which are separate threads that can be used to offload computationally expensive work from the main thread. Now that is no longer a drawback since there are worker threads. If you have an intensive task that requires 5 minutes and CPU processing power, this worker thread will offload that task from the main thread and take care of it, while the task will welcome any incoming request. So that is just how the single threaded event loop works. I believe we all understand what a single threaded event loop is and how it actually handles asynchronous operations in Node.js and makes it non-blocking. Moving on, we have the CommonJS modules, which we discussed in our previous class. In one of our previous classes, we discussed the module system and we discussed CommonJS modules. And today we'll still go over it once more, making it more understandable. So Node.js was introduced with CommonJS modules as a system. And this system structures JavaScript code into reusable modules. It was widely used for server-side development with Node.js before the introduction of ES modules, that is the ECMAScript modules. So the key characteristics of the CommonJS modules are they are synchronous, they require function, and then the module exports object. So what makes it synchronous? CommonJS modules are synchronous. This means code execution is blocked until a module is fully loaded. So if you have a module that will have to take about, let's assume 30 seconds to load, code execution will be blocked for that 30 seconds. And after the module is done loading, your code will continue executing. And the require function is used in importing and using a module. The modules are imported using the require function. So what this require function does is it takes the path to the module as an argument and then returns the exported content of the module. It only takes the path as an argument and then returns its content, the exported content. So module.exports the module export is an object. It's just an object used to define what they want to make available to other modules. It assigns a value to module export, set the exported content of the module. So when the value of the content you want to export is being set to this module export object so that other modules will be able to access it and then import and reuse the logic. And we actually demonstrated this in one of our previous class, but let's kind of demonstrate it once more. And let's assume we have two files here. Use the index, and let's add another file. Let's call this one as a test.js. And in our package using file, let's remove type of module so we don't get errors. And let's zoom in a little bit. Zoom, okay, I think it's okay. Okay, so let's clear terminal. Then do away with this. And in here, let's assume we have module exports is equal to an empty object. Now, if you hover over this, file is a common JS module. It may be converted to an ES module. That is a module exports this. Okay. So we don't want to use ES modules. We want to use common JS modules. So in here, let's assume we have this an object, and the key here should be, let's say, add, which will return a function. And this function is actually defined, but let's say an anonymous function with no parameters and no function body. But in here, let's say we want to use the function. So how do we get access to this function? Or how do we get access to the add method in this test file? You can simply say const. We can even use the name of the file. Test is equal to require. And in this require, we pass in the name of the path to the file we want to get the content from. And the path here is test. Like so. Now, if you try to log, let's log test to the console and see what we got. Node index, yes. And now we have an object. And this object contains the add method with this function. The function is the add function. Can you see it? So how can we get access to this add function and actually make use of it? Let's say we have to say test add. Let's log it to the console and see. Now we've destructured the add. We can even say something like const add is equal to test. We can destructure this and then we can say log add, like so. We can see that add is a function. Now, if you call this function, it should return. Let's call it and see. It's doing nothing, returning void, and you actually get undefined. But then let's go back and then add parameters to our function. Let's say a, b. They return a plus b. Or we can make this an arrow function. A, b, a plus b. Make it a one-liner. And then come here, passing 2 and 3. Then run the function. We have 5. So what this require function here is doing is when you give it a path to a file, it will grab all the contents in that file to be used in another file, to be reused anywhere else in your code. So we give it this part, it looks at this file and then grabs all the content in this file. And this file has an object. So it grabs this object, and this object will return all the method inside of it. We have the add, and we can add another one. So now we have access to all the content in this file, so we can destructure it and use all the methods in that object. So that is simply how the CommonJS modules work. Okay, so now that we've seen how basic the CommonJS module is, what are the benefits of the CommonJS modules? Some of the benefits are modularization and dependency management. So they promote code organization and reusability by allowing you to break down your code into smaller, well-defined modules. And dependency management, yeah, CommonJS modules can have dependencies on other modules, like the require function helps manage these dependencies. So you can go ahead and take a look in depth at the require function and how it works under the hood and all of that. Okay, drawbacks. What are the drawbacks of the CommonJS modules? So the synchronous loading, as I mentioned earlier, is a drawback, and the global namespace pollution. So the synchronous loading can block the execution of code waiting for a module to load. And the global namespace pollution, if modules are not carefully exported, they can pollute the global namespace, leading to potential name conflicts and all of those. So we also looked at the ES modules, which were introduced later in 2015. ES modules are asynchronous. Like if you use the import statement and the export statement for export, they are now the preferred way to write modular JavaScript code in modern environments. So now they are the preferred way to write modular JavaScript code. Why CommonJS was the traditional way for modules in NodeJS? NodeJS now supports both CommonJS and ES modules, so you use them accordingly depending on your own use and how you want to actually use them. Next on our list is the callback pattern. Now, in Node.js, the callback pattern is a fundamental approach for handling asynchronous operations. What it does is it allows your code to initiate an asynchronous operation and then continue executing other tasks without waiting for the operation to complete. As we learned earlier, the core idea is broken down in simpler steps. So it initiates asynchronous operations. You start an asynchronous operation, such as reading a file or making a network request, or actually querying a database. Now, then, when you initiate an asynchronous operation, it provides a callback function associated with that asynchronous operation. So you pass a callback function as an argument to the function that initiates the asynchronous operation. So this callback function contains the code that should be executed when the operation finishes. And we'll see to that in a bit. Event loops and callbacks. So when the asynchronous operation completes, Node.js will add the callback function to its event loop queue. Now, when the event loop gets to that very callback function being added to its queue, the event loop, which continuously monitors for events, it will trigger that callback function when it gets to its turn. It will trigger the callback function from the queue. Now, when the callback function is triggered, the callback function will receive the result of the asynchronous operation, which is actually maybe an error or success, and then execute the code that you define within it. So for instance, let's say we have a function that reads a file. And let's say we have let's assume we have a file here. Let's create a file of let's say name.txt. Inside of this file, we have KodeCamp. And then we have JavaScript. We have NodeJs, like so. Now, we want to read the content of this file inside the index.js. So what we will do here is, first of all, Node.js has an inbuilt function for file operations. It's actually a system, an inbuilt system, because it has other functions associated to it. It is known as FS, that is a file system, and it can read a file synchronously or asynchronously. It can write to a file and you can delete a file, all of those. But in this example, we're going to be using it to read a file. So since we're using common JS modules, we'll say something like const fs is equal to require fs. Now we use this fs to read a file, which is a name.txt. But first of all, we use to implement a custom function that reads a file and then log its content on the console if there is no error. But if there is no error, it first of all handles the error without logging the content of the file. Now let's say we have a function to read a file. Function, let's read file, like so. Now this function will take in two arguments. First one is the file name. The second one is the callback we're talking about. The callback that will be associated to it. Now inside of the function body, what we do is we say fs read file. We don't want to read file synchronously. We want to read it asynchronously, like this. So what this read file takes as arguments is, it takes, first of all, it will take the file name to read from. The second one is the encoding. And encoding we have UTF-8 16 little endian, UTF-8, UTF-8 16 little endian, and base 64 binary, hex, Latin, ASCII, and all of that. But what we need is UTF-8 because we want the content in a human readable form. Now, it will take, this read file will take a callback function, which accepts the error and the data arguments. So this error is the error that it will return if an error occurs, and this data is the data that will be returned if the function successfully complete its execution. So we first of all handle the error. We say if error, we invoke the callback with the error argument. And in this callback, this error argument is being passed as a parameter. Else, if there's no error, we want to invoke this callback. And since the first argument is the error, we pass in null because there's no error. And then we pass in the data, like so. We are just emulating this read file because this is how this read file is kind of built under the hood. But in our case, we are not using the FS. We're just using the FS to build our custom read file function. So now let's make use of our custom read file function. Say read file. So what is the file name? When we call this read file, first of all, we passed in a file name. Now let's pass in our name txt. The next thing is a callback function. This is the callback here. This callback passing as an argument here. Let's use it now. This callback now passing, we accept arguments of error and data. Now you understand the reason why when there's no error, we first of all pass in null, then data, because it accepts two arguments here, error and data. So if there's error, we first of all handle the error. But if there's no error, so if error, let's just log the error to console. So what am I doing? Console error, like so. So if there's no error, that means there will be data. So we log the data to the console data, like so. Okay, so now let's execute our file and see what we've got. Clear our terminal first. Now, we've got the file content, which is KodeCamp, JavaScript, and NodeJs. And now let's change the name of this file to something else, a file that doesn't exist. So we run it again. And this time around, we have an error. No such file or directory to open. That is the name txt. The system call here is open. The code is ENOENT. The error number is -2, and the path is name txt. So inside this error, let's add something to know this is where the error is. Error, like this, and then run it once more. Now you can see error, and then we are handling the error first. But if we don't want to do that, we will simply call the fs read file and then do the same thing. But we just implemented our custom read file to actually understand what's going on under the hood. So don't allow it to become too complicated in your head. Just try to understand what's going on. FS module has a read file. This read file takes the file name, that is the path to where the file is, and then a callback function. As we earlier stated, this is an IO operation. So this callback is then the callback associated to this function will be pushed to the event loop. And once this function is done executing, this callback will be executed with the result. If it's an error, the callback will be executed with the error. If it's data, the callback will be executed with the data. Okay, that's how simple it is. Okay, so what are the benefits of the callback pattern? The benefits are just asynchronous. The benefits are just asynchronous programming and simple for basic use cases. Okay, so Timothy is asking, what if you return the callback data without the null? Okay, so we're still on it. Let's just try it out and see what we've got first. Now let's remove this null. And then it's just a kind of best coding practice, one of best practices to enhance code readability. This time I change the name to name, and then Can you see what's happening? Instead of logging it on the console, we are logging it as an error, which is not acceptable. We are logging error on the console. Here now, it's taking the first null or data. Since there's no null, this data is acting as the first argument, which is supposed to be error. Error here is the first argument, data is the second argument. Since we are handling the error first, error is the first argument. You can actually do something like error and null. But since error is the first argument, there's no need for null. Just leave it like that. And we're handling error here. But if you don't add null here to say error is null, data will become the first argument and it become the error, which will be logged as an error to the console. So that is the reason why null is added here. So you have to, now we have our data logged to the console instead of an error. So Timothy, I hope your question is answered. Okay. So we're trying to look at the benefits of the callback pattern. So the benefits here are asynchronous programming and simple for basic use cases. It's basically easy to use and understand for beginners in asynchronous programming. Then it enables non-blocking I/O, allowing your code to remain responsive while waiting for asynchronous operations. It also has some drawbacks, which are callback hell and error handling. We already know what callback hell is, and it can make error handling cumbersome, especially in complex code with multiple callbacks. So we have some alternatives to the callback pattern. These alternatives are promises and async await. Async await, there are still promises with a kind of added sugar. So promises provide a more structured way to handle asynchronous operations instead of using the traditional blah, blah, blah of T. In using promises, you can actually do something like, instead of this read file, you can do something like here, comment this out. You can say this should return a new promise. I text in a function, a executor function with resolve and reject, like so. And inside of this, we grab this here and then move it inside of this promise. Then if there's an error, we reject the error. We reject the error. But if it is, we have resolve reject. Okay, if we have data, we resolve data like so. And now we have our code reading. Now we don't even need, we can actually, okay, we have a callback here. We can actually pass in the callback and then resolve, okay, callback and all of that. Then anyhow you want to handle it. Okay, the callback here, this is the callback, and then we pass in our callback. I'm not undefined. Okay, we resolve our data and then invoke our callback here as it is. New promise resolve reject. But this is how you can just use promises. You can pass in the callback, and here no still undefined. Oops. And what am I really doing else? Go back. If there's an error, reject error. But if there's no error, all of that. Okay, so that's basically it. Let's not waste time there. Okay, so that's how you can actually solve that with promises without using the traditional pattern and callback whatsoever. Anyhow you want to go about it. And we have the error first callbacks. As you can see here, we are basically handling the error first. That's what we're doing. We're handling the error first. That's why in this callback, we have the error arguments first before the data. So the callback function passed to an asynchronous function always has two arguments, the error argument and the data argument. So the first error argument is reserved for errors. So if the operation encounters an error, this error argument will contain an error object with the details about the error. So if the operation is successful, the argument will be set to null. Now let's change here the name, because the error is actually an object with the error details. Then you can say log error dot let's say error dot path. And here we have, there's the error path. We have error code, because this is an object. This you can actually destructure it. You can say const past path, the code is equal to error. And in here you can say log the path and the error code as well. And if you run this, you have error, the path is named nam.txt and the error code is ENOENT. Okay, so that is an object, and our data can be an object or simply any specified data type. Can be a number, a string, or an object. So that is how we first handle errors, and then we handle the data. So moving on, we have design patterns. The basic design patterns in NodeJs. So design patterns are well-established solutions to recurring problems in software development. So they provide a blueprint for structuring your code to be more reusable, maintainable, and scalable. Reusable in the sense that the patterns promote code reusability by encapsulating common functionalities that can be applied in different parts of your application. Then the maintainability, it makes code where design patterns makes code easier to understand, modify, and then debug as well. Patterns can help you structure your code in a way that can be easily extended to accommodate future growth. That makes patterns scalable. So in Node.js, we have some common design patterns used in Node.js development. These patterns are categorized. We have the first category, we have the creational patterns, we have the structural patterns, second category, we have the behavioral patterns, and these are the basic three categories of patterns in Node.js. Okay, so under the creational patterns, we have factory pattern and the singleton pattern. So this factory pattern centralizes object creation logic, allowing you to choose the right type of object to create based on specific criteria. And the next is the singleton pattern. You can take a look at I will definitely have to prepare some notes for you so you can head on with the research. The singleton pattern ensures that only a single instance of a particular class exists throughout your application. So this can basically be useful for managing global states of configuration. And then under structural patterns, we have the module pattern and the adapter pattern. So the module pattern is a way to organize code into reusable modules that encapsulate private data and functionality, promoting modularity and information hiding, as we know about the common JS modules and the ES modules. So we also have the adapter pattern, which allows incompatible interfaces to work together by converting the interface of one class to form another class. We also have the behavioral patterns, which contains the callback pattern, promise pattern, async await, and the observer pattern. We already know about the callback pattern. We know about the promise pattern and the async await, but we don't really know what the observer pattern is. This observer pattern establishes a one-to-many relationship between objects, where one object maintains a list of its dependencies and automatically notifies them about any state changes. This is a pattern that is used for building the publish/subscribe systems. That's the pub/sub. And if you don't know about the pub/sub system, you can go make some research. So how do we choose the right pattern? So the decision of which design pattern to use depends on the specific problem you are trying to solve. Below are some factors to consider. What problem do you want to solve? The complexity of the problem. You consider also code readability and performance. So what specific challenge are you trying to address? And how complex is the functionality you are trying to implement? So you also, if with this pattern, make your code easier to understand and maintain. And are there any performance implications of using this pattern? And you should always remember to use design patterns to provide a clear benefit to your own code. You just don't use them because they exist. Use them by understanding and applying them appropriately to your own code or your own design. So moving on, we have the middleware pattern. This is another pattern not included in the pattern just mentioned. And I believe one know what the middleware pattern is because Express uses the middleware pattern. So the middleware pattern is a powerful design pattern that actually allows you to intercept and manipulate requests and responses before they reach their final destination. So it essentially creates a chain of functions. So this is a middleware. The chain of functions is known as a middleware that each have the opportunity to process the request and respond to objects. So the core concept behind the middleware pattern is, let's assume you have a request coming into your NodeJs application. So instead of going straight to a specific route handler, it passes through a series of middleware functions, one after another. So each middleware function can access and modify the request and response object. It can terminate the request or response cycle by setting a response itself. So it can also pass the request and response object onto the next middleware function in the chain. So the benefit of the middleware pattern is modular code. Middleware promotes modularity by separating request handling logic into smaller reusable functions. And then the cross-cutting concerns and flexibility. You can also implement common functionalities like authentication, login, or error handling in middleware, making them applicable to all routes in your application. You can easily add, remove, or reorder middleware functions to modify the request processing flow. And in common use cases, you already know the use cases of the middleware pattern: authentication, login, passing request body, and error handling. You already know how to use the middleware pattern in Express.js. So last but not the least on our list is dependency injection. So dependency injection, simply known as the DI, is a design pattern that promotes loose coupling between objects and their dependencies. So it essentially shifts the responsibility of creating and managing dependencies from the object itself to an external mechanism. And as I earlier said, we are not using Express in this camp. We are using Nest.js. We're not using Express.js, we're using Nest.js. And Nest.js uses the dependency injection pattern. It doesn't use middleware pattern. Express.js uses middleware pattern, but Nest.js uses dependency injection pattern. And when we start building APIs with Nest.js, we understand very well what dependency injection is. But mind you, we're not just going to jump into building APIs with Nest.js. First of all, we still have a lot of work to do, going through TypeScript and understanding how useful TypeScript is. And then we use TypeScript to build a task manager server that you can actually, without using any framework, we just use Node.js, plain Node.js with TypeScript to build this task manager server. And we build it to the production level. We also host it on fly using SQLite in production. So we all stays code and we experience a lot. In our next class, we will simply clear out advanced JavaScript features by complete the Node.js philosophy and design patterns, and then we also look at streams and event emitters because they are very, very important. If you don't understand those, you won't understand what actually the problem Node.js or Next.js solves. You won't understand the problem they solve. You just think they are just there for nothing. But we'll get to that in a bit. So the benefits of dependency injections, it improves testability, and it encourages loose coupling, also flexibility. So by injecting dependencies, you can easily mock or stop dependencies during testing. So it allows you to isolate and test the behavior of your object without relying on external factors. And then loose coupling, this reduces tight coupling between objects, making your code more flexible and easier to maintain. You can change the implementation of a dependency without affecting the dependent object. So that's great. It also enables easier switching between different implementations of the same dependency. That is the flexibility it provides. Then techniques for dependency injection. We have the constructor injection, the setter injection, and the dependency injection containers. So dependencies are passed as arguments to the object constructor function in the constructor injection. In the setter injection, dependencies are injected through setter method on the object. And the dependency injection containers, frameworks like Inversify.js or TypeDI can help manage and inject dependencies throughout your application. So in as much as, let me just demonstrate a bit of what the constructor injection is and how it's being implemented. I'll just give you a simple example. The example may be meaningless, but it's still an example. So in our code, let's assume we have a class of car service like this. Nope, this is a class, and then it has a constructor. This constructor takes in car, let's say car repository like this. And inside of this, we see this.car repository is equal to car repository like this. Then we want to get car. So get car. You can get the car by ID. You pass in the ID. Then what you do is you return this car repository dot get car by ID. And then you pass in the ID being provided like this. So let's assume we have a previous service here of class car repository. Let's say car repo. And in here we have a constructor. Let's assume we have an empty constructor. And then we have a method that gets car by ID. It's an ID, and then it returns this dot car. And then we can see here car. Oops. So this car is equal to car, like so. And if you want to use this, let me just draw this. Okay. ID this dot car. Let's say this dot cars. This dot cars is equal to an array of cars. We have car 1 and car 2 like this. Just remove this car. Move this dot cars ID like so. Now let's assume the ID is an offset of this array. We can just say const car repo is equal to new car repo like this. Then we can say const car service is equal to car service is equal to new car service. And then we pass in the car repo. So while passing in the car repo, what do we want to do? We want to actually get the car. Then we can call this method here. The car service has a get car. You can see car service get car, and we pass in, let's say 1. Let's run our code. Okay, let's log this to the console. Log something like this. and we have car 2. And if we change this to 0, we have car 1, because we're using the IDs are actually offsets to this array. So as you can see, this is a car service that is independent to this car repo. This car repo only store cars and then retrieve car by IDs. And what the car service does, it takes this car repo as an argument, and then initiates it in this object where there's a get car by ID in the car service, where it searches the car repo and then calls the car repo method to get the car by ID. So this is simply a simple example of a dependency injection. So it's actually a valuable pattern for building more maintainable, testable, and flexible NodeJs application by decoupling objects from their dependencies. But one of the reasons why I don't like DI dependency injection is it can introduce some boilerplate code, especially for simple applications. Then deciding whether or not to use DI depends on the complexity of your application and the potential benefits of loose coupling and improved testability. So it all depends on you, right? It all depends on you. Now, you can even go ahead in here. Instead of passing this here, what you will do is come here and say this that car repository is equal to new car repo, like this, and then remove this. And you call this is a car repo get ID, call this, you still get the same result. As you can see, instead of passing it as an argument to the constructor function, you are not passing it, you are just calling it directly here. Then let's assume you have an argument to this constructor function in the car repo. You can actually pass it in this constructor and then pass it to this car repo, decoupling this function. This doesn't know what this is doing, but then you can call the method and then get to use it effectively. So that is just what dependency injection is. And today, as I earlier mentioned, the class won't be long enough. So what we learned today, we iterated over philosophy and design patterns of NodeJs, which we looked at asynchronous and non-blocking I/O. We also looked at the single-threaded nature, the single-threaded event loop nature of Node.js, and also the common JS modules, callback pattern, error first callbacks, design patterns, middleware pattern, and dependency injection, which we just looked at. This dependency injection is a kind of an advanced concept in coding. Let me not just in JavaScript. It's kind of an advanced concept, but we will understand it better when we start building APIs with Nest.js. Meanwhile, you should also try to go make some research on databases, understand what SQLite is, understand the advantages and disadvantages of using SQLite in production. As it is, SQLite is only used for testing, according to what people normally say, but I don't believe that's true, because Fly makes it possible to use SQLite in production with master-slave architecture using the Fly FS, that is the Light FS, that is the Light file system. And we'll see to that in our subsequent classes. In our next class, we look at the event loop and streams, and why streams are very important in building applications. When dealing with large amount of data and the event emitters, how to emit events, how they are important in building real-time applications like chat applications, or real-time applications like GitHub, where an event is triggered, an action is triggered, and all of that. So we'll look at that in our next slide. But for today, I think we call it a day. Thank you all for being present, and sure to Timothy, I will update the repo, and I will also try to regrade those that have submitted their task and made amendments. So we come to the end of today's class, and I hope you all enjoyed today's class. We call it a day, and possibly we will meet in our next class, which is on Friday, and we'll discuss streams and event emitters with some examples, and we'll understand how they all work.